Good evening, everyone. Welcome to today's session of Mission Aditya. I'm Shalini, and it's my pleasure to introduce our esteemed educator. Today's session will focus on Mission Aditya, and our educator Agatha Ma'am will share valuable insights, strategies, and expertise to help you achieve your goals. We are excited to have you join us on this learning journey. Agatha Ma'am is a renowned expert in physics, astronomy, and physics with a passion for empowering students to achieve their full potential. And also today she is there to explain us about the session of Mission Aditya. So, Agatha Ma'am is an enthusiastic and dedicated astronomy educator with a strong foundation in observational astronomy, computational methods, and astronomical data analysis. She holds dual master's degrees, one in astrophysics from the University of Hertfordshire in UK and another in physics from Pondicherry University, India. A combination that highlights both her theoretical knowledge and hands-on research experience. Her approachable nature, strong communication skills, and adaptability make her effective in engaging students and igniting their curiosity about the universe. As an educator, Agatha combines subject expertise with empathy to create an inspiring and intellectually rich learning environment. Her teaching spans a wide range of topics from the mechanics of rockets and satellite missions to the mysteries of exoplanets, encouraging learners to explore both the science and wonder of space. So over to you, Agatha ma'am. We welcome you to give the very opportunity and the valuable learning opportunity to the students where they will be learning more about this Mission Aditya session. Over to you, Agatha ma'am.
Thank you so much, Shalin ma'am, for your kind words. And hi, everyone, myself Agatha. And I'm really grateful to have this opportunity with NASO team to deliver my knowledge to the young future kids. And yeah, let's have the session. Okay. So now, as we speak, we know that we are in the journey towards our monsoon season, right? We are in the middle of June, July, almost at the end of July. So everyone over the India, mostly southern part, will be having the rainy season happening now. So as we speak, the monsoon as we speak about the monsoon season, what we are lacking? We are lacking the sunlight, isn't it? Can you see the sun all the time during the rainy season? Okay, so as we speak, the monsoon, we are lacking the sunlight. We are not having the proper sun during the entire day, right? So how do we observe sun during these kind of time? So the clouds are hiding the sun behind it, so we won't be having the natural sunlight. We won't be having a method that we can observe the sun from the earth, right? So for that we need some mission or something that we need to observe the sun during entire time, so that our study for the study about sun, it would be better. So if we have the clarity about sun during the entire time, we'll be having more data regarding the sun. We won't be having a breakage in between, maybe saying because of the rainy day I couldn't observe the sun. So for not having such kind of issues, we need some other answer, right? For that we need a mission. So I'll be sharing my screen so that we can continue the session. So hope everyone can see my screen. Give me a thumbs up, please. Okay. So for that, we need a mission, right? To observe the sun during the entire time of an year. For that, we have Mission Aditya L1. I'll be speaking about Mission Aditya L1 during the entire session. So please stick around. So my question is, since I already told you we need to observe the sun during the entire time, but can we fly to the sun and look at it? Is it possible? Can we fly near to the sun and go near to the sun and click pictures? Is it possible? Or do we need something else for that, any kind of property, prop, or some other vehicle? Do we need something to send from Earth to sun? Or can we itself as an astronaut, can we go to the sun? Is it possible? So I'll be expecting answers from you guys in the live chat. Yes, no, right? We can't fly ourselves. For that, what we need a vehicle or some prop that we can send to sun, right? So here you can see a satellite. Am I right? Yes. So we need a satellite to send click pictures of sun and many other spectrometers, some other data that we need to collect for our studies. So for that, we need satellites to be in the atmosphere, be in the space for the entire time to observe the sun or clicking the pictures or study about the sun, so that every single day without a fail we'll get to know about the sun or any other object that we are observing. So ourselves couldn't go, but who can go? Satellites can go, right? So now I have a question. Do you know which spacecraft was sent by NASA to go very close to the sun and study about it? So I have a couple of answers here. So option A is Mars Orbiter, option B is Parker Solar Probe, option C is RISAT, and option D is IRNSS 1A. So now you can comment or you can go to your live chat and send me the answers. You don't have to write entire answers. You can give me the option A, B, C, or D in the chat, and let's see who all can guess it right. Okay. I am getting few answers. Yes. I can see a couple of right answers too. So yeah, the right answer is Parker Solar Probe, which was sent by NASA to study about sun and clicking the pictures of the sun. So NASA sent Parker Solar Probe to the atmosphere or the space to study about sun. Okay. So our Indian researchers, scientists also developed a satellite which we can study about sun. And ISRO made it possible through several experiments, and we made a satellite. Here you can see the picture of the satellite, and the name of the satellite is Aditya L1. So this is our own satellite made by India to study more about sun. So can anyone guess the meaning of Aditya? Any particular reason why we gave the name Aditya for this particular mission? Yes, please put your answers in the live chat so that I can see your responses. So do you guys have any clue what Aditya means or what that name actually, what is the meaning of that name? Yes, right. It means sun. Yes. So the mission itself is given the name of the sun. And yeah, so here this is our satellite that we have sent to space to study more about sun. But my question is, where is Aditya L1 flying to? Is it flying near to the sun, very close to the sun or the surface of the sun? If it go near to the sun or closer surface of the sun, does it survive? Any guesses? Or is it just roaming around in the space? Or is it going into any particular point in the space? Do you have any guesses for that? So yeah, obviously it can't go near to the sun, right? Or surface to the sun. So it is going to a point we call as L1. Okay. So L1 is nothing but a point in space. Okay. So here in my screen, you can see two magnets, right? In the left, you can see a bigger magnet. So yeah, here in left, you can see a bigger magnet, right? Yes. So in the right side, you can see a in the right side, you can see a smaller magnet as well. But here my question is, in the middle, we have the metal ball also. So what generally a magnet do? It attracts the metal ball, right? So if there is a magnet and a metal, it will attract it. Am I right? So here there is two magnets. One is a bigger one in the left side, as you can see, and in the right side you can see a smaller one, isn't it? So here my question is, which magnet will attract the ball? Is it gonna be the left one or is it gonna be the right one? So can you please send your answer so that we can move on? So please let me know which magnet will attract the ball. Is it going to be the left one, which is bigger and stronger, or the right one, which is smaller than compared to the other one? So let me see the live chat. Right, okay, I'm getting both the answers. Yeah. So one more thing here you have to consider is that, is the magnet on the left side and the magnet on the right side, is it at the same distance? No, right? So the bigger magnet, which is bit far away from the metal ball, and the smaller magnet, which is closer to the metal ball, isn't it? So here, even though the magnet in the left side is big enough, but it is very far from the metal ball. But the smaller one is very close, but it is not that strong enough. So the effect on the magnet would be less. But it is in a way that the bigger magnet and the smaller magnet is having a similar or same effect on the metal ball. You can consider one more example. I can give you one more example. So let's say you are doing a tug of war, but the ends of the tug of war, one side we can consider a dog and the other side we can consider a rabbit pulling from each side, and the dog is bigger, as we know, is pulling from a distance, but the rabbit is pulling from closer, and in the middle we are having a teddy bear. They are fighting for the teddy bear, so they are both pulling the ends of the rope, and one very distant and one closer to the teddy bear. So who do you think who is gonna win, or does both of them are gonna get the teddy bear? So what do you think? Who's gonna get? Whether the dog is gonna get or the rabbit is gonna get? So I'll be expecting answers from you guys in the live chat. So who do you think who's gonna get the teddy bear? Whether it's a dog or it's a rabbit? or are they gonna end up in a tie? Both of them doesn't gonna get, or it stays still. So yeah, I'm getting both the answers. Yeah. Yes. Okay. So I'll tell you. Here, the dog is very far and the rabbit is closer, and they are pulling at the same strength, same way. But since the bunny is closer to the teddy bear and the dog is very far, what happens? The force on the teddy bear is same, so that it doesn't move each side. Similarly, here in the bigger magnet, it is also pulling from this end, and the smaller magnet is also pulling from the other end, but it is very closer to the metal ball, so it is stronger. But here what happens at the left side? It is far away, so the strength would be less, isn't it? So what happens? The metal ball stays still in the middle. Is it clear for everyone? So now we are going to replace the magnet with sun and earth, and the metal ball with the satellite that we are sending. Okay? So here what is happening is that here sun is also having the force. So here sun is also having the force on the satellite, and earth is also having the force on satellite. So what happens? Sun is also trying to pull the satellite, earth is also trying to pull the satellite, isn't it? So here, do you know what kind of force, what sun is pulling or the earth is pulling? Is it magnetic force? Do you think? Is it the magnetic force or any other force? So let's see the answers. Yeah, someone said yes, gravitational force. Yes, correct, exactly. So the sun is also having a gravitational force and earth is also having a gravitational force. So both the force from sun and earth is on the satellite, which is in the middle. So earth is pulling and sun is also pulling with the gravitational force, so that what happens? Our satellite stay on a point where the both the strong force is affecting, and but it is stable in a place in between sun and earth. I hope it is clear for everyone. So this point where the satellite is actually staying in the space is called L1 point, which is Lagrange point 1. Am I clear? Okay, so we are sending our satellite to this specific point to observe the sun and click the pictures of the sun even during our rainy season, so that we can click pictures in the monsoon, so that no clouds is hiding our sun. Isn't it? Isn't it interesting? So in our space, there is 5 points where we can have the Lagrange or the stable point. Those are given here: L1, L2, L3, L4 and 5. So we have 5 Lagrange point in the space, and Mission Aditya L1 is specifically mentioned L1 because we are sending the satellite to this particular L1 point. Isn't it interesting? So now I have a question for you guys. Quiz time. So does the L1 point orbit the sun with Earth? Or my question is whether the L1 point stay in one particular point itself, or is it orbiting the Earth? Is it orbiting around the sun? So you can give me the answers in the chat box or live chat, and you can give the options. I have given option A as yes, B as no, and C it stays still, and D it orbits the Earth. So let me see the answers. Yeah, I can see a couple of answers. Okay. Okay, yes. So I'm getting couple of answers. So the right answer is the Aditya L1 is actually orbiting around the sun. It's not staying still on one point. It is staying still, but that is in between. Here you can see that in the picture. So L1 is a point in between sun and earth, right? But here you can see a red circle where where the satellite orbits around the earth according to the earth rotation or revolution. So here what happens, what earth is doing, earth is also rotating this way, right, around the sun. Over the year, one complete year, earth is rotating around the earth is revolving around the sun. And similarly, at the same time, our Aditya L1 satellite is also orbiting the sun. Okay, so it is in a way that the satellite and the earth and the sun is maintaining the same, the satellite and earth is maintaining the same path during the entire journey of one revolution around the sun. Okay, so it is not a point where it stays still, but it is a point where it orbits the and orbits around the sun with the earth, so that what happens when sun pulls, earth pulls, give the force, what happens, the satellites stay. So every single day we are earth is moving around the orbit around the sun, right? Similarly, our Aditya L1 is also moving around the sun. Hope you guys got the concept. And here I have given a 3D image how the Aditya satellite goes in the space. So here you can see from Earth, the Aditya L1 is having the orbit. It is launched into the orbit and it is rotating around the Earth. And then after a while, it is in a place where it is orbiting around the L1 point. Okay, so here in this picture, we can actually clearly see the journey of Aditya L1. Here, sorry. Yeah, here you can see that from Earth, what is happening? We are launching the satellite and then it is orbiting around the Earth. And again, it is orbiting around the Earth. After a couple of rounds, what happened? It is going outside the gravity of the earth. We are giving thrusters, right? We are giving thrusters, and when it escapes the gravity, it starts its cruise phase. It starts its cruise phase. It is a long journey from Earth to this L1 point. And here we have mentioned that it is almost 1.5 million kilometer away from our Earth to that particular L1 point. So do you think it is an easy journey? So this journey of Aditya L1 took almost 4 months from Earth to that particular L1 orbit. Okay, so here what is happening is that after escaping the Earth's gravity, it is having the cruise phase, and again what is happening? There is an orbit around L1 point. It is not directly going to this L1 point. So what is happening is that the satellite is orbiting around the L1 point. It is not constantly going to stay in the L1 point. That orbit is called halo orbit. So after the cruise phase, it is entering to that halo orbit so that it can orbit around that point, L1 point. So here you can think that our satellite is actually orbiting around that L1 point. It is not constantly in one point. It is actually having an orbit around the point, Lagrange point. Okay. Hope the concept is clear. So now we can take off our journey towards the sun with Aditya L1 as well. So now it's our time to build our own satellite Aditya L1, and we are gonna start the journey with satellite Aditya L1. So for that we are mainly using magnets, and you know how magnet works. Two magnets will always attract, so we are going to have fun with magnets. So also we'll be providing a printout so that you will also be able to have an hands-on experience on the Mission Aditya L1 journey. So you will get the kit, then you will understand assemble the kit, and I'll be sharing the video how you can assemble the kit. So I hope you are able to see my screen. So now So now we'll be having a hands-on experience on the journey of Aditya L1 satellite. For that you need a couple of accessories like scissors, glue sticks, pair of magnets and also a glue drop. And here you can see the printout of Mission Aditya. This will be available in the description box as a link. Also it will be provided in the QR code which I will be sharing later on the PPT. And also you will be needing a cardboard, or also you can use an old book binding to stick the printout on top of the cardboard. So what you have to do is, first you have to take your printout and start sticking it onto the cardboard. Now we have pasted our printout on top of the cardboard box. Now we can see a curved shape here. You have to cut through the curved shape first to build your satellite. So now you have a piece like this. Now you can see the piece here, the dotted lines, you can cut through it to make your own Aditya satellite. now you have your satellite to go to the L1 point, and what we have to do is, to start the journey, we have to stick the satellite on top of one of the magnet that we are using. You can either use a glue drop or you can use the same glue stick that you have. So now I have made my satellite and I have put it on one of the magnet, and what you have to do is you have to place the magnet on top of the earth, and the other magnet, the second one, you can put it under the sheet so that it attracts the top one. So here you can see we are ready to start our Mission Aditya with the satellite you have built yourself. So now we are ready with our satellite, good to go. So here you can see, are we directly going to the L1 point? No, right? We can see different orbits around the earth where satellite has to make its journey. So now we are going to start our journey of Mission Aditya L1 using our own satellite. So we can start from earth, okay? So now what I'm going to do is, I'm not going to start move the satellite. Instead of that, what I'm going to do is, I'm going to move the magnet which is under the sheet, as you can see. So here what you can do is, you can move the magnet around the orbit that is given in the sheet, and you can follow the arrow through the orbits. So I am doing the journey towards L1 using all the orbits given in the sheet. So we are going in a way that the satellite has to rotate the earth at least 4 times, and here you can see I have completed the 4th orbit, and again from here what is happening is that we have given the thrust so that it can escape the earth gravity. So now it is a long journey towards the L1 point, and this we are calling it as a cruise journey. And here again we have reached near to the L1 point, and I can't directly go from the satellite to the L1 point, right? So for that, to enter the orbit around L1, I have to again do a rotation so that I can enter the halo orbit around the L1 point. Now once you are in the orbit of halo orbit, what you can do is, you can rotate around the L1 point and stays on the orbit itself. So using the satellite, we have traveled all the way across Earth to the L1 point, and we have covered almost 1.5 million kilometers using our satellite, and we are in our perfect destination at the moment. So I hope you guys had fun making this kit and traveling through the space using a satellite. So I hope everyone could make the satellite Aditya L1. So now I hope you can see my screen. Okay. So now I hope you all can see my screen, right? Yeah, it's loading. So during the journey, do you think the satellite had any challenges that had come across in between Earth and to that L1 point? Can you come up with any challenges that the satellite might had gone through? Maybe in outer space, we can have so many satellites, right? So many thousands of satellites are roaming around the outer space of Earth. Am I right? So what if it goes and hits some other satellite? Also, we can have asteroids coming in between. So Aditya L1 is a mission that actually considered all the difficulties and still made through its journey towards L1. and it was a successful mission from India to the sun. So now I have a question for you guys again. And we have talked a bit about the L1. Repeatedly, you guys have been hearing the word L1 again and again. So now my question is, what does this L1 stand for? I have mentioned it, I believe. So you have an option here. Option A, luminous spot. Option B, launch phase. Option C, Lagrange point 1. And option D, light zone. So can you please answer me in the live chat so that I have the knowledge that you understood what the L1 point actually is. Yes, yes, yes. I can see right answers here. Yeah, it's nothing but the Lagrange point. Right. So Aditya L1 meant to Lagrange point. And I have seen a couple of queries regarding where you can get the stencil printout. So here you can click a screenshot or you can take a picture of this QR code and you will directly go to the link where you will get the stencil of the Mission Aditya L1. So I'll screen it. The QR code will be in the screen for a couple of seconds. So if you want to take a screenshot, you can please take the screenshot. So you you will get the stencil, and later when you do your mission to the Aditya to the L1 point using the Aditya satellite, you can get the printout from this particular stencil, and you can have your own journey towards the L1 point with the satellite. So hope everyone could take a screenshot of the stencil. And now I'll be providing another QR code where you can see the worksheet of this particular kit. Also, I'll be sharing the worksheet. And before that, you can click a screenshot or click a picture of this QR code so that you will be having you will be able to access the worksheet of Aditya L1 mission. So I'll give you some time. And yeah, congratulations. Now your mission is very successful, and I hope everyone could make their own mission Aditya L1 and their own satellite and have a journey towards the sun. Okay. Now, it would be better if you can ask any queries regarding the session, regarding any doubts regarding Aditya L1 and the mission, the journey. If you have any queries, please let me know in the live chat so that I'll be able to answer. Please post your queries in the chat box so that I can answer you guys. Yes, I'm getting a couple of queries. Okay. So someone asked, what is the meaning of Lagrange? So that it's not a word or its meaning. It is a name of a scientist called Georges Louis Lagrange, and he was a astronomer and also a mathematician who was like 18th who was there in the 18th century, and he made couple of big discoveries. So we are naming the particular point as Lagrange to the honor to that particular scientist called Joseph Louis Lagrange. So any other? Yes, I can see a question regarding what is L2. Okay, I can share my screen again. So here you can see all the points, right? So here L1 is there, L2 is there, L3 is there, L4 and 5 is also there. So someone asked, what is L2? So L2 is nothing but a point in the space where the combine effect. So I already mentioned these points are the points where the force of gravity of two objects are constantly giving upon a body. So here L2 is having the effect of Earth and also Sun. So here L2 is nothing but the combined effect of Sun and the Earth, the gravitational force from Sun and the Earth. So here L2 is the point where the force of Earth and Sun acting on. And here we have an interesting satellite in the L2 point. Satellite, or you can call it as a telescope. It is nothing but our James Webb telescope. So our James Webb telescope is actually staying in the L2 point in the space. Okay, I hope it made sense to you. So someone asked, what is halo orbit? So halo orbit is the orbit around the L1 point. So the L1 point, as I mentioned, it is the combined effect of Sun and Earth, right? So of the gravitational force. So L1 point, we can't just park our satellite just in the L1 point. What our satellite is doing is that the satellite Aditya is actually orbiting around the L1 point. It is not like other satellite orbits around the Earth. The Aditya satellite is also orbiting around the L1 point. It is not constantly orbiting, constantly staying in the L1 point. It is orbiting around the L1 point. That orbit is called as halo orbit. So, yeah, the codes are for the stencils and for the workshop, and it is also mentioned in the description box. You can take the link from there and you can check out the stencils and you can make your own Aditya L1 mission. So, yeah, I can see. So why was Aditya L1 made for? Aditya L1 was a mission that is made from Indian scientists to send a satellite to study specifically about sun. I think to learn about sun is also very mandatory when it comes to astrophysics or astronomy. So other telescopes or other satellites which we use for communication, broadcasting, etc. Like that, we need a permanent satellite which study about sun. So that was the goal of the mission and it was very successful, and I'm happy to share that with you guys today. So yeah, how many days it will take to reach? Yeah, from Earth to the L1 or halo orbit, the mission Aditya took almost 4 months to have the cruise phase or to cover the entire 1.5 million kilometers. So you can calculate, if you want, if you have time, you can calculate how speed the Aditya L1 gone. So it had covered 1.5 million kilometers in 4 months. Pretty interesting, right? So yeah, I think that's it. I think yeah, that's it. I believe. I hope most of what I said you guys could was understandable, and I really wish you guys make the journey towards Aditya L1 using the kit provided, and I really hope you guys have a very good journey throughout your life in this particular domain also, and also in your life. So yeah, and I wish a very good luck for the NASO preparation for you guys. And yeah, that's from me. And thank you so much for attending my session. And yeah, just stay